All right. Welcome to lecture 7. This is going to be the first optional lecture, so, no more homeworks from now on. Yeah, I hope the hack challenge is going well for everyone, but for now, let's get started on authentication. Cool. So, just to recap a little bit, what do we know about sending requests? Well, for this class, we've been using HTTP communication, right? Which, you have some client, which is, some front end, some computer, which is sending a request to a server, which recall is just another computer, right? And then the request is going to have whatever information the front end wants, right? So it's going to have the URL so that we can translate that via the DNS and actually access the backend. It's going to have query parameters to say what we're looking for, or a body. It's going to have a method like get, post, or delete, or put, or options is a fun one. We haven't talked about options much in this course, but options is another HTTP method. And the whole point of options is it's like, hey, hit this endpoint with options, and it'll tell you what HTTP methods are allowed. So it'll be like, oh, you can get and post to this. Anyway, side tangent, I just think it's cool. And then you return a response body and a status code, right? All right, that's what we've been doing this whole class. But, for a lot of applications, you need users, and you need a way to figure out which user is making a request, right? If you're on YouTube and you say, okay, fetch my feed, you don't want it to, fetch the generic feed for everyone, right? The whole point is that YouTube personalizes these recommendations for you. So we need to figure out who's making this request. In YouTube's case, it's, because you're logged in through Google. But how do we do this? How do we verify who's sending the request and not just let people imitate other people, right? One thing you might think to do is just pass in which user is making the request in the request body. This is problematic for hopefully clear reasons, right? I could easily masquerade as someone else, or if this was my request, somebody else could just be like, hey, I know Rahi's username, so I can submit that in my request body as a key, and that's not something we want to be that easy to do. We want to kind of protect people, right? So we need some way to authenticate. The basic idea is we're going to have some additional information that'll help protect users' identities and uniquely identify them, right? So on the front end, that'll store some information related to the user. On the back end, we'll validate whatever information is stored to make sure the person sending the request is really who they say they are. And then you can access specific things based on who you are, right? Maybe you're an admin, maybe you're a normal person, maybe you're trying to access your subscriptions, etc. Cool. So the first step is going to be, registering and then, repeatedly logging into something, right? So how does that work? Well, let's say you have a basic sign-up form, right? You're trying to create something, so you put in your email and you put in your password and then you click sign up. Well, one thing you might do is you could be like, okay, send this username and password to the database, encrypt things, just so if you have a database leak, it's, more secure, and then store it. Okay. And then on every subsequent request, when the user wants to log in, they put in their stuff, and then that gets sent, and then that gets sent to the database. And the database is like, oh, yep, this is a match. We have stored these two things paired together. You're validated, right? Well, how can we store this, right? And I guess more to the point, that's kind of problematic for a couple different things. But, first, how are we going to actually submit this information? Well, we don't want to put it in, the request body itself. The request body is really for more pertinent information about the request, right? Who you are isn't necessarily a part of the request so much as it is kind of meta information about the request, right? This is being like, oh, I'm making the request, and that'll probably change what you do, but it's not really changing the request itself, if that makes sense. It's kind of a semantic split. There's a couple different things that are stored in headers. Content type, for example, we've been using content type JSON mostly in this class. Cookies are often used to store this kind of information. And then authorization is also used to store this kind of stuff. User agent just kind of is like, oh, you're using Chrome on a Windows computer or whatever, So this is an example of what request headers might look like, right? You can just see a bunch of different headers here. You have the method, it's a post method on Dropbox. You have the content type, which is an octet string. You have a bunch of cookies. you have, you know, the path, which is /comment/post, etc. And all of that is stored in headers. So there are a couple different methods we have to authenticate users. The first one is the most simple and the most security flawed, and that's going to be HTTP basic. So with HTTP basic, it's pretty much exactly what I explained earlier. You store the username and password in the database, encrypted, you know, and then you cache that on the front end, and then in every request, you just resend that, right? You don't want the user to have to re-put in their information, so the front end will just cache their username and password and send that every time, and the server will just validate it every time. That's, as an example, this is how an authorization might end up going. You, in the authorization header, put an encoding of the username and password, and that's how you pass it on to the server. You can see we're using basic to say, hey, this is going to be basic authentication. So yeah, this is pretty much what I said earlier. You register, you create a user, and you be like, yep, cool, user created, cool. Front end is going to store the information, and then in subsequent requests, it's going to pass in the credentials. The server will decode it, check that it's okay, and then be like, yep, that user exists, or sorry, unauthorized, you're not the right person. Cool. So it's nice from the perspective of, you know, one, it's simple, right? So it's going to be easy to code. It's kind of agnostic to the front end, right? You just have to be able to make the authorization header and then you're good. There's no specific integration you have to do with a front end service, right? So you could have a backend that has a bunch of different kind of front end types linked up to it this way without really having to coordinate them. That's nice. But every single time you send a request, the username and password is exposed, right? And you might be like, well, that's not the biggest problem. But, you know, it is shockingly easy to figure out requests being made on your local network. So let's say you're, you know, just chilling in a Starbucks trying to access various things you're logged into, maybe things you want to keep secret, stuff like that. If somebody happened to be running one of those programs that was just trying to scrape information off the network, they could very easily get your username and password. If someone was malicious and trying to steal that kind of stuff. And, you know, people shouldn't, but a lot of times people's passwords are going to be very similar to each other. So if they get one of your passwords, they're going to get a lot of them, right? The other thing is, you're storing someone's username and password on the front end, right? That's questionable practices at best. If somebody, you know, got access to that machine somehow and just looked inside the local files, they could find it with, you know, a little bit of effort, but they could do it. You know, it would be removed if you close something, which could be annoying, right? Because that means every time you have to reopen your browser or reopen your app, you have to all of a sudden log back in again. Maybe you don't want to log in every time you open the app. Maybe I don't want to have to say that I go to Cornell every time I open the Get app, right? And then the other thing is you are relying on an external service for security, right? If you're not using HTTPS, this is just like raw out in the internet. You could just like see this. That's not great. HTTPS is the more secure version of HTTP, and it's a little bit harder to set up. You do want to use it on like any major application, but you know, you want to be able to set up your own security too. So, what about HTTP session? Well, this is another authentication method. This time what happens is you send the username and password to the server. Server's like, okay, let's store that. And then the server's like, I'm going to make you a cookie. Now I'm going to give you this cookie, right? And then, you know, the cookie will go bad in a little bit. But until the cookie goes bad, just give me the cookie every time you want to make a request. And I'll check to make sure I've got a matching cookie in my database, right? If this cookie's still tasty, we're good. So what does that look like? In this case, you know, you have a bunch of different cookies, and then one of them is going to be storing some authorization information. Oops. In this case, do you see this SES ID? That stands for session ID, right? And so you can see that it's a big number, and then it has some expiry information. But yeah. So first, the client registers by sending their information, and the backend creates a new user, right? you also have to create a new user session. And then associated with that session, you create a cookie. And you're like, hey, this cookie is going to expire at some point, just so you know. But you give it back to them. The client's like, cool, I'll keep chewing on it until it goes bad, then I'll let you know. So in future requests, the client just sends the cookie. There's no need to send the username and password, so that's less exposed. Right now you're just sending a cookie. The server will then be like, hey, is this cookie good? Do we have a session that corresponds to this cookie? We do? Perfect. Let's return that then. Or it'll be like, hey, you just tried giving me an expired cookie. I can't eat that. Excuse you. Take it back, I don't want it. In which case, you're going to get an expired and the front end's going to have to re-log in, right? So every so often, the front end will have to send their username and password, but it's way less frequent, right? It's only whenever the cookie expires, and you can kind of decide when your cookies expire. This is fine. I've talked about that. So yeah, you get to decide the expiration time. You get to avoid continuously sending the username and password, so that's good. And you know, for some applications you might want it longer, for some applications you might want it shorter. It's really you know, if you delete your cookies, you're going to have to re-authenticate. You're still sending over your username and password relatively frequently, at least every so often as a cookie expires. And you have to save session data somewhere, right? You have to save the user's password and stuff somewhere, right? That brings us to 3 HTTP token. So the idea here is you send the username and password, and this time it's going to be very similar. You create and return an access token, and that gets cached on the front end. And this time, the access token gets sent on every request, right? So this sounds very similar to the cookies, right? In this case, it's called a bearer token, so you can see authorization is bearer, and that's what the token looks like. But this time, we don't really have a need to store someone's password. Well, we do. We have to make sure that their password's valid. So, you know, in some user table, we're going to be storing some encrypted version of someone's password, but we won't be having to access that as often, you know, in case there's some database leak around. But more importantly, we can take these access tokens and fine-tune them with expirations, exactly like cookies. The biggest thing is we can add refresh tokens now. And the idea of a refresh token is, hey, if the access token expires, they can then send the refresh token and request new tokens, right? So a diagram will probably help this. Yeah, you make a token table and it references the users. That's fine. So you register the user, you pass in the username and password, and we store that. So then we create a new user. We also create new tokens, plural, right? We make the access token and the refresh token. And then we return the access and refresh token to the front end. Perfect. So the front end is going to cache these tokens. And in every feature request, it's going to send the access token. We're going to be like, cool, that's a good token. Do whatever you want us to. And now we know who you are because that access token is uniquely going to identify you, right? Or we're going to be like, hey, that token is not good. Either it's expired or it's not a real token, right? One of the two, we're just going to let you know, bad token. Could be expired, could just be bad token. In which case, the front end can then just send the refresh token that they've stored. The refresh token will be checked on the backend and validated to make sure it's a good refresh token that we have stored, and then we will replace the access and refresh token with new ones and return. So it's a very similar process to signing up, right? We're creating new tokens. It's just that this time, instead of requiring the username and password, we just require the refresh token. So the username and password are being sent significantly less in this token model. It's a lot more scalable than session cookies, right? You don't have to store things for every session. You can just replace what you have. Yeah, those are the 3 HTTP auth schemes. Hope you all enjoy the demo. Thanks.
Hey everyone, welcome to Demo 7. In this lecture you'll learn about different authentication schemes including HTTP Basic, HTTP Session, and HTTP Token. And for your HTTP Basic, you learn how to pass over your encoded password through a header to the server and authenticate yourself to be able to do stuff. One drawback of this is that you're always sending over your encoded password to the server, and this gives attackers many more opportunities to intercept your password, and from there, who knows what they'll do. To deal with this drawback, we then introduced HTTP Session, which is much better because we only need to send our password once, and then we'll have a session token that we can use instead, which we'll be able to use until it expires. The only drawback is that when it expires, we need to send over our password again. So that's why we discussed HTTP token, where instead of having to send over our password again to get a renewed session token, we can instead use our update token, and that will generate a new session token and a new update token, and that way we only need to send our password once, ideally, which we can get to in the demo. Before starting to implement the demo first, I did want to go over the final solution so that we can have an idea of what's actually going to be implemented. So let me start that up right now. And this is where it's running. So let's go on Postman and let's run the get. So we're getting hello world, meaning that our app is running properly. So we have 4 routes. Since we want to authenticate ourselves, we need a register and a login route. So let's start with register. If I'm trying to register, I need to pass things in, and I can do that with a post body. So we want to pass in our email, which I will use my own. And we also want to pass in a password. We'll say ABC123. So when we send this, the user already exists. Oops, oh, it looks like I need to clear out the database. Let me refresh that. Okay. Let's see if that still happens. Oh, okay, wait. Let's just restart the server. Okay. And there we go. So the user was already in the server before because I ran this before the demo. So we'll see that it will say that user already exists, which is one case that we need to take care of. But when we actually register a user for the first time, we're going to get this response back from the server. And we have our session token here, which is what we use to authenticate ourselves. We have the update token here, which we can use to regenerate this session token and the update token after the session has expired. And we'll also see here the session expiration, and it looks like it's 11/16. Today is November 15th, and we'll see that this is about a day after. So what we're going to do is we're going to make sure that our sessions expire a day after we we make a request to the server. So this is how you register. We can also try to log in now, and it's very similar to register. Let's first try to log in as something that doesn't exist. I'll just put an extra G in my email. We'll see invalid email or password, and we'll get our 404 not found. And then when I send again, we get 200 OK, and then we get the same response as for register. So that seems to be working. Now let us do the route where we need to update our session token and update token, and that route is session. So we want to post, and for this we want to post the update token, but we can't post this in the post body. We want to do it in the header to abide by the authentication scheme. If you want to put something in the header, we simply go into headers, and then we type in for the key authorization as in the lecture, and then the value is bearer, and then we paste the update or session token. So if I try to post this now, we'll get this, and if we switch back and forth, you'll see that the session token and update token have changed. So if I were to relog in, you'll see that they're the same. So this works too. Another way you can do this, Postman has an authorization tab, and there's multiple types of authorizations, including bearer token, which is the one that we want to use for HTTP token. So it looks like I have an old token here, so if I were to actually copy the update token, paste it here too, that will also work. And you'll see that if we go back to headers, we have an auto-generated authorization header here. We also have our old one, but it'll also say that it's overridden by the one that's generated by Postman. So we can also turn this off, and it should work regardless. So it works. But we will be using the headers tab just so that it's clear what we're actually doing. So no shortcuts for this demo. We'll just leave it as it was before. And now that we can actually update our session token, the only thing that we need to do now is actually be able to use our session token. And to do that, the route associated with that is secret. So for this demo, the only thing it does is it returns a secret message. For your hack challenge or any other backend apps you want to make in the future, you can essentially just refer back to this code and you can fill in whatever you want. So it doesn't necessarily need to be a secret message. Maybe it opens a web app, or maybe it does something else that you need to be authenticated for. So for this, we want to do similar how we did to updating our token. Go back here for authorization. We want to pass bearer and we want a session token. So let's take this one. And there we go. Hello world is a secret message. So now that we have an idea of how this works, we can actually implement this. And since we have these routes here that are doing what we expect them to do, we can use these as test cases. So we'll start with register. So let's open up, I'll stop this app, and I'm going to open up the starter code. So here we go. For app.py, it looks pretty similar to other assignments. These are the routes that we're going to implement. We have register, login, session, and secret. And then we also have this helper function called extract token, where we'll learn how to actually extract the authorization header value. For db.py, we'll go over this a little bit more. Essentially, there's code in here that will help us with all the password encoding and stuff. So let's go over this first. We'll see that we're importing hashlib for hash library and import bcrypt. So if you did the extra credit for homework assignment 2, you may have experience with these, but these are going to help us with keeping the password secure in our database. So let's actually look at the model. We have our ID, we have the email, which is a string, and we also have a password digest. Reason this is a password digest is because when we actually store the password into our database, we want to store it hashed. We don't want to store raw passwords in our database, because if anyone gets access to our database, they'll essentially have everyone's passwords. And if I also look into the database, I don't want to be able to just pick out anyone's password. So this is security for both the database manager and anyone that might steal database information. So that's why it's called a digest. We also have our session stuff. So we have the session token, session expiration, and update token, just like the responses we get back from Postman. In our init, we need to pass in an email and also a password, which is converted to a password digest through bcrypt. Make this a bit bigger. So whenever you pass something into the hash password function of bcrypt, you want to include the password and you want to encode it to, this is a UTF-8. The reason we want to encode it is because we want to make sure that the password string that we received from the client is consistent, because they may be passing a string that's UTF-16, so we just want to make sure that it's for sure consistent. And then we also have a salt. Essentially what a salt is on top of the password, it just adds some random text, and that makes it more secure. You can look these up on your own time if you're curious. And then we also want to call renew session. What we see here is it essentially generates a token, a session token and an update token, and also gives us a session expiration, which is now plus a day, meaning that it's going to expire a day from now. We'll see URL safe base64 actually generates the session token, is using SHA-1, and this just gives us some random bytes to help us do this, and then this hex digest is going to convert the hash object into a readable session update token. So that's why you'll see that this is a bunch of letters and numbers. This isn't hexadecimal. Otherwise, it'd be a very long string. We can also verify our password, and the way we do that is we pass in a password, and we'll check the password by encoding the password back to UTF-8 and checking with the password digest. The way this works is we have a password and we hashed it, but we don't. The point of a hash is that you can't convert it back. So the only way to verify that you have the password is to hash the password that we passed in and check if that hash matches this hash. And so that's what keeps the password secure. We can also verify our session token and update token, which essentially just checks, okay, did I pass in a session token that matches the session token for this user, and has it expired? So this is also important, because if it's expired, we need to renew our session by updating with the update token. And then here you can also see that it just checks to see if your update token matches the update token of this user. Ideally, this has an expiration time too. Normally update tokens have expiration times of months, and that's why sometimes you need to re-log in to Facebook or something if you haven't logged in a while. Maybe no one really experiences that because we're always on social media, but if you've ever had to re-log into something after you've logged in, it's probably because you haven't been on it for a while, and that also keeps your update token, it keeps your account more secure, because if anyone intercepts your update token and it never expires, that would be pretty bad, because then they can just generate session tokens on their own end. So this is how the user model works, and with that information we can start implementing. So for register account, first thing we want to do, this is a post, and if you remember, oh boy, okay, this is my GitHub Copilot. We are not using you today. Let's see, just globally for now. Okay, we're gonna do this all on our own. If you haven't used GitHub Copilot, it is very useful. So to register an account, first thing we want to do is, remember, we want to extract the request data. This is the post body, and from the post body we want to get the email and our password. Now we want to check to see that they did provide an email and password, otherwise how are they going to register an account? So let's check to see if these are both none. And if they are, we can return a failure response, which defaults to 404. We'll say invalid email or password. We don't want to say invalid email and then have another response that says invalid password, because that might help an attacker figure out, oh, I have the email right, but what's the password? So we don't want to do anything like that. We can just be as vague as possible. So from here, we have the email and the password, and what we want to do now is just create the user. So we will create a function in db.py, we'll say is called create user, and we want to pass in an email and a password. We can get to this, but let's just finish what the route is going to look like before we delve into that. So from not having cleared the database before starting this demo, we saw that if we try to register an account that already exists, we get a failure response. So we do need a way of knowing if a user already exists. So maybe something that would be useful is if we also make create user return some boolean called created, and if it actually created something, we know that we created a new user. If we didn't, then we should say the user already exists. So we can say if not created, we'll return a failure response. User already exists. And then we can probably say something like this is a 403. Forbidden, you shouldn't be able to register a user if it already exists. After that, all we need to do is return the response that we saw from the actual solution here. And we can do that by returning a success response. And we'll have a dictionary. We want to have a session token. And remember, we can get the session token from the user. So user.session token. We want to return the expiration date. And we can do user expiration date, or I think it's session expiration. One thing with this though, if we go back to the database, we will see that the session expiration is represented as a datetime object. And JSON does not support that, so we should cast this to a string to make sure that it looks right. And then the last thing is the update token, which we can also get from the user. Okay, looks good. Now let's actually create this helper function. So we'll save this and let's go into our db.py. We'll go all the way down here. It takes an email and a password. Now, first let's focus on actually creating the user. So how would we create a user given the email and password? Well, I can just use the constructor of this class. Pass in email is equal to email and password equal to password. The reason why I want to do email equals to and password equals to is because if we look at the initializer, it's using kworks. So it takes in a dictionary, and that's how it knows to get these fields. So once we have this user, remember that we want to add it to the database and then commit. So db.session.addUser, db.session.commit, and then we can just return true because we created, and user because we need the user. Now, how are we going to check to see if a user already exists? There is something special you can do with SQL Alchemy, which is querying and then filtering for a certain condition. So the password is a password digest, so that won't really be useful, but the email should match up with the email in the user model. So let's try filtering that. So let's have a Boolean say, or let's say if we get the user successfully, say we have an existing user that equals to, so we type this by having the class name. We want to query and then filter by, I want to filter by a field of this class, so user.email, and I want to check to see if this equals to the email that I pass into this function. This is going to give me a list of results because it's possible that there's multiple objects that actually match this condition. But we know that if we at least have one user, then there should be an existing user. So we can just get the first element of this list. Now, if existing user is not none, or well, if it's not none, then we want to go through this. But if it is none, wait, no, I'm doing this wrong. This is right. If it is not none, then that means that we have an existing user. So we want to return false because we're not going to create a user since it already exists. And then it doesn't really matter what we return here. So we'll just return none. I'll save this. And then we go back. So if this ends up being false, we check. If not false, this is true. And then it goes through here. So this looks like it should work. Let's run this and verify. Oh, I need to run it from the starter. So same IP. Let's try to see if this works. I will send the post. Looks like it worked properly. Let's try again. Good. So we covered this case. We can cover this case. We can try, I'll just put like a email. So we're missing an email. Now this works too. And then we cover everything, failure response, and we got the success response. So we covered all 3 cases. It looks like everything's working here. Actually, so technically, because I typed in 2 M's, this should be a 400 because it's a bad request. But we'll just say 404 so that we don't give enough information. Maybe this is a register, so I guess we can just do 400. That won't hurt anyone. So we do this, we can try again. Invalid email password, 400. That works. Okay, so this is working properly. Now let's try to implement login. Login should be very similar to register. We want to, of course, get everything that's passed into the post body. And then from here, we want to also verify that everything is received in the post body. Now the new thing is we don't want to create a user. We want to verify that the credentials are correct. So here, we're just going to try to verify credentials, and then we'll pass an email and a password. Although similar to up here as well, if the credentials are not correct, we want to return a failure response. So let's have a Boolean here too. We can call valid creds. So if the credentials are invalid, we want to return. So here we can just say, oh, wrong email or wrong password, but then that gives away too much information about whether or not an attacker is actually getting the email or the password wrong. Some systems take care of this by only giving you 3 options before you need to send email recovery or whatever. But just for this, we can just copy and paste this. And then they won't actually know if they are getting the email or the password wrong. And we can just say that this is going to be a 404 by default because they did not find a user. So this looks fine. Last thing we will want to do is, just like up here, we want to return this same body. Exactly the same. And then we have the user from this function that's giving us this information. So let's actually implement verify credentials. Verify credentials. We take an email and a password. So we want to check to see if the user already exists. So we're going to do the same thing here. But this time we actually do need our user to exist. So if our existing user is actually none, then we actually want to return false and none. Because our user, we can't verify our credentials if the user doesn't exist. Now to actually verify whether or not our password is correct, we need to use one of these functions, specifically verify password. Now check PW, check password, is going to return a Boolean. So we want to return the Boolean here, let's just say true for now. And we also want to return the existing user, assuming that the password is correct. So, we can return this regardless, because we're only going to use this here, assuming the password was correct here. So this is fine. Here now, we actually want to use our user's verify password function. So we can use that by getting the existing user's verify password, and we want to pass in the password. So, assuming the password is correct, valid creds should be true, otherwise it's going to be false, then we don't bother using this. So let's save this, and let's save this. And it already reloaded over here, so we can just go here and try running. So, these are the same credentials? Nope, okay, well, I can just fix that, but it shouldn't make a difference. Let's try to see if it actually logs in properly. And it did. Let's try to, so we tested this works. Let's test to see if the invalid email is not working. Email 400, that's fine. And now let's type in the wrong email, GGG. That should be a 404 because this actually hit this case because the user doesn't exist, GGG. Now we can also do this, user does exist, but wrong password. You get the same thing, it's vague. You don't know if the user doesn't exist or if the password is wrong. So we keep our system safe through that obscurity. So this is working properly now. And we can start on how to actually update a session. Now, to update the session, remember that we need to implement extract token because we need to extract something from the header. So the first thing we want to do is, let's just make a call to extract token. We can say we want to get the update token eventually. And we want to extract the token. And if we go up here, this takes in a request, so let's just pass in the request. We can get to that, but let's say we do have our update token. We want to verify first that we did pass in an update token. So if they didn't actually provide one, then that means that there is some kind of error. So we can have a Boolean here called success, just to verify whether or not the update token, there was an error with parsing it or something. And we can just cover all cases like that. So if there was an error in extract token, we can return a failure response. And then if we do this, so the reason we want to do this is because I can't just pass in a response from here, because that will just cause some, how do you say? It's just going to be difficult to do this. This is a simpler way of doing this, where if this is not successful, then I can put an error message here. In fact, how about, let's just leave this. When we implement this function, it should be easier. I'll implement this function first, because this is kind of confusing. So let's just go over here. If I want to extract a header from a request, all I have to do is request.headers.get, and then I want to pass in the key I want to get, because a header is just a dictionary. Remember, I want to get the authorization key, and that should give me my actual token. So we'll do token. Now, the token isn't actually the value. The token is, or the value is bearer space token. So I want to get rid of the bearer and the space part so that I can actually get the token. So I can just parse this by doing token.replace. I don't want bearer, so I can replace that with an empty string. And then when I do that, I'm still going to have a space in front. So I can just do strip and I'll get rid of all white spaces around it. Now, if for some reason my token, or actually I want to do this before here, before I even start doing this. If I never passed in an authorization header, or an authorization key in my header, then token is going to be none. So if that is none, I want to return something. Normally I'd return a failure response, but the difficulty with this is that this is a helper function. So instead I'm going to return what I would pass into the failure response. So remember that we're getting a success Boolean back, and we're also getting the token. So success was false. And now I'm just going to pass in the error of this that I should put into the failure response. And so I'll just say we're missing the authorization header. So if we actually go back down here, that's what I was talking about here. So if I wasn't successful in doing this, I'm going to return the failure response, and now update token is the error message that I want to return. So yes, sorry about that. That was a little bit confusing, but hopefully that is clearer. So once we've done all of that, if the token is actually there, we can just try to replace, and then we're just going to return true because it was successful, and we'll return the token. So this should work fine. So now we have a token. Now what are we going to do with it? We want to verify that the token that we passed in is actually the update token. And remember that the user has a reference to that. So to do that, we need to check to see if our token is valid. So we're going to have a function, another function, to renew the session with the update token. And this is going to check to see if the update token is valid. Now, just like our functions from before, we're going to have a Boolean first to check was it actually valid, and then we'll also pass in the user. We'll also return the user so that we can have the success response at the end. So we'll check if not valid. I'm going to return a failure response. Remember that it's an invalid update token. And then otherwise I return my success response, always the same. Now we're going to leave these because these are going to actually be updated in this function. So let's save this and let's go back here and create that function. This is renew session, which takes in an update token. So first thing we want to do, does the user actually exist given this update token? Before we check to see if the user existed given the email, remember that we have an update token associated with a user. So we can actually check to see if an update token is valid by looking up the user with that update token. So we can just copy this. And instead of filtering by email, we filter by token, update token. Now, if the user doesn't exist, we can just return false none, just like how we do in verify credentials. Now the user does exist. So what do we need to do to renew the session? Remember, there's actually a renew session function in the user that will generate a new session token and an update token, and it will also update the expiration date. So we just have to call this. And remember, because we changed some attributes of existing user, we need to commit these changes to the database. And having done all of that, we can return that we have a valid update token, and we can return the user associated with it. So this looks like it should work. Let's test it out. So let's actually take this update token from the login. I'm going to go here. Do I have this off? Yes. Okay, so I'm just going to go into this authorization. I'm going to replace this with this update token. Let's post. Looks like it updated. Let's check this. This also updated, so that is working properly. Let's check our error cases. What happens if I never provided one of these? I'll post missing authorization header. Looks like it's working. Recover all cases. We got this one. Right, now we need to check to see if the update token is invalid. So this is the update token now. This is the old update token. So let's just try to post and see what we get. Invalid update token. So we covered all cases. This is working properly too. So the last thing we need to do is actually use the session token to get our secret message. So it's this function here. Very similar to update session. We just want to copy this because we want to extract a token. This is no longer the update token, this is the session token. And we want to also check to see if we were successful with this. So very similar structure to before. Now, here we renew the session, but now that we've checked the session token, we want to verify that it's a valid session. So that's all we care about. We can just check to see valid, and then we want to verify the session is correct. Oh boy, we'll finish on time. Let's make a helper function here real quick. Verify session. How would I verify the session? We'll just check to see if the user, if any user has a session associated with them, or the session token associated with them. And that's what we've been doing here all the time. So remember, this is a Boolean, so all we need to do is return this Boolean. Instead of update token, we want to use session token. Save that. So now we're back here. So if it's not valid, we have an invalid session token. And if it is valid, we can return our secret message. So return a success response that says hello world. We can save that. Let's go back here, close this, and let's see. If I try to get now, I'm going to get invalid session token because this is the wrong one. So let's go into the login. I think this is the most recent one. Before we try that, let's just turn this off, see what happens. Send that. Missing authorization header, so that's also good. And now let's actually pass this in. And there we go, secret message. So that's essentially how you would implement authentication into your app. If you are interested in using a third-party library, such as maybe Google Login, or you want to do Apple Login, there are APIs for that. You'll be using OAuth, and essentially you get a token from them on your front end. The front end sends it to you through a route call that you implement, and then you pass that token into their API, and then they can tell you whether or not that token is valid. So sometimes you may want to prefer that, because then you can keep all of your authentication even safer using maybe Google Login, and you won't have to store any of the authentication information. And they won't need to create an account on your platform because they already have Google accounts. So that's really it for this demo. Next lecture will be about images and how to store images in your database, and how to send them over to front ends as well. So thanks for watching this demo, and I hope this was useful to you.